this is how we're going to calculate revenue. Revenue is equal to the number of items sold multiplied by the price per item. And that's how we came up with that 800 at first, right? There were 100 items sold, they each cost $8, so the revenue was 800. This sales manager wants to increase that revenue by making the bottles more expensive. But he's going to sell fewer bottles. But there is a point in there where he can increase up to a certain point and he'll still make more money. If we look at sort of that, if he just increased it once, we said he would sell 95.
Yeah.
So at $8 each, he's making $800 in a week because he's selling 100. If he charges $10, he's selling only 95, so he's selling fewer bottles, but what's his revenue?
760? No.
950, right? $10 times 95 bottles. So is it better for him to sell them for $10?
Yeah.
Yeah, because he's going to bring in more money. He's going to sell fewer bottles, but bring in more money. We want to figure out how much can he increase it and still be making more money. And what's that maximum value? So we're going to write this equation, and because revenue is what we're trying to maximize, we always need to figure out what are we trying to optimize here. And in this case, it's revenue. Let's try to write the equation. We need to think about what we're maximizing. That's the first thing, and I'm going to call it R. What are we varying here? So what's changing?
The price.
The price and the number of items sold, right? And they both change depending on how many times he increases the price. So our other variable is going to be the number of price increases. To write the equation, it's going to be revenue is equal to number of items sold. So I'm going to look at originally, how many items is he selling in a week? 100. And then that number is going to decrease. So subtract. It's decreasing by 5 for every price increase. So actually the number of items sold is 100 minus 5x. Started at 100, and then it decreases, so that's why it's minus 5 bottles for every price increase. So 5x. And then we need to multiply that by the price per item, which was originally $8, but it's going to increase by 2 for every price increase, so 8 plus 2x. That's the hard part. Once we get that, then it asks us to rewrite it in vertex form. So I know we can do that. I'm going to expand this. So I'll multiply 100 times 8, 100 times 2x, and then negative 5x times 8. And negative 5x times 2x. And I just want to get this into standard form. It started out in factored form, well, sort of. It's not fully factored, but partially factored form, which we don't really use a lot. I want to expand it and then put it, first of all, in standard form. So that's going to be negative 10x squared. I'll combine the x's, so I get plus 160x plus 800. Now this is the part where we're just going to follow that process of putting it into vertex form. So factor out the negative 10 from the first two terms. That comes to x squared minus 16x. I'll leave a space to complete the square. So I need to figure out what goes in here. Half of 16 is 8. 8 squared is 64. So I'm going to go plus 64 minus 64. Most of you seem to be pretty good at this part by now. Just the switching from standard to vertex. The A part, that's the new stuff. This is the old stuff. This becomes x minus 8 squared. Oh, I kind of skipped a step. Maybe I shouldn't do that yet. You're not ready. X squared minus 16x plus 64. I'll leave that inside. And then I want to take that negative 64 out. I have to multiply it by the negative 10. So that comes to plus 640. I still have the plus 800 there. We're almost there. Negative 10 times x minus 8 squared plus 1440. So there's the equation at the top in vertex form. And it says, what does the vertex represent in this situation? First of all, let's just look at what is the vertex. 8 and 1,440. What does that mean in the context of the problem? 8 is the number of price increases. So, and 1,440 is the maximum revenue. So what does the vertex represent? A maximum revenue of $1,440 can be made by increasing the price 8 times. Because remember, when we have an ordered pair, it's two things, right? And in this case, it's X. This is X. And R, because we used R instead of Y. X represented the number of price increases. We need to increase the price 8 times. R represents the revenue, and because it's the vertex, it's the maximum revenue. And then it asks you the question, what price should the manager set for the water bottles? So instead of selling them for $8, he should sell them for $24. Because 8 price increases, it was $8 plus every price increase is $2. And do that 8 times, so 8 plus 16, $24 is what he should sell them for. This is another type of optimization problem that's pretty common for you to see. This one says a farmer wishes to build a corral with 100 feet of fence. So he has this fencing that he's going to use, and he has 100 feet of it. He wants to maximize the area of the corral. He'll build it against his barn, using the wall of the barn as one side. So you have like this barn, and he's going to build a corral on the side, like that. And he has 100 feet of fence to use, and he wants to know how big should he build it, like what should the width be, what should the length be, to get the maximum amount of area with that 100 feet of fencing. So he could build a really narrow strip along the whole barn, or maybe he could do something that comes out further, but is narrower, kind of that way. We don't know, but we're going to find out. What kind of equation are we going to write? So we need to think, what are we trying to maximize here or optimize? The area, right? So we're going to write an area equation. If area is what we're trying to maximize, then we need to write an area equation. And we already know that area is equal to length times width. So I'm going to call this x along here, that width, x. And the other one then also is x. What we need to find out, because we can't use length and width, that's two different variables, we need to only use one. So I'm going to use x for the width, but then I need to figure out what to call the length in terms of x. So if he has 100 feet of fencing to use here, here, and here, and he uses up x here and x here, how much is left for that part? We don't want to use a different variable, right? We don't want to call it y. But we need to take that 100 feet of fencing, take x of it away from here, take x away from here, how much is left? So that's what we're gonna do. 100 minus x and minus x again. So 100 minus, 2x. That's what we're gonna call the length. And then when we go to write the equation, it's gonna be area equals the length, which is 100 minus 2x, multiplied by the width, which is x. So again, that's the hard part, right? Coming up with that equation. Now the easy part, we're gonna switch it into vertex form. First I'm gonna put it in standard form. I'm gonna go negative 2x squared plus 100x, and that's just by multiplying that out, 100 minus x and negative 2x minus x. To switch it into vertex form, this part's fairly easy. Take out the negative 2, x squared minus 50x. We need to figure out what goes in there. So half of 50 is 25. 25 squared is 625. So plus 625 minus 625. So we have negative 2, x squared minus 50x plus 625. I'll take the negative 625 out and multiply it by negative 2. Comes to 1,250. So we get negative 2x minus 25 squared plus 1,250. I know I went through that pretty quick, but this you should be getting good at by now, like I said before. There it is in vertex form. The hard part was this, that first original equation. Once we've got it, put it into standard form by expanding, and then put it into vertex form. First of all, what is the vertex? What are the coordinates of it? 25 and 1,250. So what does the vertex represent in this situation? Remember, it was x and a that we had. So what's the maximum area that he can get with that 100 meters of fence, or 100 feet of fence? Yeah, 1,250 square feet. How does that happen? How does he get to that area? 25 on each side, right. The maximum area of 1,250 square feet occurs when the width is 25 feet. Remember what that diagram looked like? We had the barn and then the corral on the outside. That 25 goes here on the sides because that's where the X was. So that's the width. What are the dimensions of the corral that the farmer should build? 25 by 50, right. So 50 is going to be this length, because remember that was 100 minus 2x. Or you can just think of it, if you used up 25 for each side, there's 50 left over. So 25 feet by 50 feet are the dimensions that he should build.